Visual: a scenic irrigation canal cutting across countryside with bridges and water channels. Welcome to Civil Engineering Edge, your learning hub for everything construction and infrastructure. In today's video, we dive into a critical aspect of irrigation engineering: cross-drainage works. When an irrigation canal intersects with a natural drainage line, like a stream or river, we need a special structure to manage this crossing. That's where cross-drainage works, or CD works, come into play. These are essential in canal irrigation systems to ensure smooth and safe flow of both canal water and natural drainage, without interrupting either. Cross-drainage structures not only help prevent flooding and waterlogging, but they also maintain the integrity of canal water levels, which is vital for crop irrigation. Whether you are a civil engineering student, a practicing engineer, or a builder, understanding CD works is key to planning efficient irrigation networks. Let's explore the types, selection criteria, design considerations, and real-world applications of these fascinating structures. Types of cross-drainage works. Visual: diagrams of canal and stream intersections, animation of water flows. There are 5 major types of cross-drainage works used in irrigation systems, depending on the relative levels of the canal and the drainage. 1. Aqueduct. The canal passes over the drainage, used when the canal bed is above the drainage's high flood level. 2. Siphon. Aqueduct. Canal passes over, but the drainage flows under pressure, i.e., pressure that is a suitable when canal is above but not significantly above the drainage level. 3. Superpass. The drainage passes over the canal, used when the drainage bed is higher than the canal. 4. Siphon. The drainage flows under the canal with pressure, like a pipe or closed conduit, applied when the line is higher and flows with hydraulic head. 5. Level crossing. Both canal and drainage meet at the same level with controlled gates, used in flat terrains where flow can be regulated. These structures ensure uninterrupted water delivery and prevent damage to canal infrastructure during floods or heavy drainage flows. Selection of a suitable type of cross-drainage work. Visual: terrain maps, canal and riverbed levels, water level graphs. The selection of a suitable type of cross-drainage work depends on multiple engineering and environmental factors. 1. Relative elevation. If the canal bed is higher than the high flood level HFL of the drainage, an aqueduct is preferred. If the higher, a superpassage or drainage siphon is considered. 2. Discharge capacity. The volume of flow in both canal and drainage affects design. Higher bridges may require wider spans and stronger foundations. 3. Available headroom for structures involving pressure flow like siphon aqueducts. Vertical clearance must be evaluated to avoid backflow or surcharging. 4. Soil conditions. A foundation design is heavily influenced by soil strength, water table, and permeability. Poor soils, deep foundations, or raft slabs. 5. Construction costs and materials. In remote areas, the availability of construction materials and transportation may dictate structure choice. 6. Maintenance accessibility. Structures requiring frequent cleaning or gate operations, like level crossings, should be easily accessible. 7. Hydraulic losses. Structures involving bends or pressure flow may cause energy loss. Minimizing this ensures better water efficiency. Hence, field surveys, hydrological studies, and cost-benefit analysis are all crucial in choosing the best cross-drainage solution. Various types of aqueducts and siphon aqueducts. Visual: cross-sections of aqueducts and siphon aqueducts 3D models. Let's now look closely at the aqueduct and siphon aqueduct, 2 common CD works where the canal passes over a drainage line. Types of aqueducts. 1. Type 1. Canal supported on masonry or RCC trough. Oh, canal is carried in a closed trough over piers. Oh, suitable for small canals or where the water level is controlled. 2. Type 2. Canal in earthen embankment with drainage in culvert below. Oh, canal flows in retained earth banks while the drain passes in culverts. Oh, more economical for medium discharges. 3. Type 3. Combined trough and embankment. Oh, the central section has an RCC trough, while sides are earthen embankments. 4. Pipe aqueducts. Oh, for low discharge canals, the circular or rectangular pipe carries canal water. Types of siphon aqueducts. 1. Barrel-type siphon aqueduct. Oh, canal flows in an RCC barrel and drainage flows under pressure flow condition. Oh, requires ventilation shafts to avoid airlocks. 2. Inverted siphon design. Oh, drainage flows in a curved profile or pipe under the canal. Oh, can be used where vertical clearance is low. 3. Multi-barrel design. Oh, several parallel barrels used to carry drainage flows for wider canals. The key difference is in hydraulic conditions. In an aqueduct, both flows are free flow. In a siphon aqueduct, the drainage is pressurized. Proper design ensures no leakage, minimum head loss, and durability under long-term use. Design considerations for cross-drainage works: visual, engineering drawings, structural models, flow simulation animations. Designing cross-drainage works involves multiple interdisciplinary aspects, from hydraulics and structural engineering to geotechnical and environmental studies. Key design considerations: 1. Hydraulic design. Ensure adequate waterway area to carry the maximum expected discharge. Use Manning's formula for open channels and Darcy-Weisbach for pressure flow. Provide flushing sluices for sediment removal. 2. Structural design. Design for dead loads, live loads, hydrostatic pressures, and earth pressures. Ensure proper expansion points in long aqueducts. For siphons, account for uplift pressures and pipe bursting forces. 3. Geotechnical investigation. Conduct soil tests to determine safe bearing capacity. Design foundations to resist settlement and sliding. 4. Hydrological safety. Structures should be designed for 100-year flood or site-specific recurrence interval. Provide escape channels and scour protection. 5. Seepage control. Use impervious linings, cut off walls, or grouting to prevent leakage. 6. Alignment and aesthetics. Smooth transitions between canal and CD structure to reduce turbulence. Blend structures with surroundings in urban or eco-sensitive areas. 7. Economy and maintenance. Balance cost with durability. Use precast elements where possible. Allow for inspection points and access ramps. 8. Environmental and social impact. Avoid affecting nearby habitats or agricultural lands. Include provisions for wildlife crossings if required. Conclusion and summary. Visual. Recap of all types, real-world examples, 3D overview of an irrigation system. To summarize, cross-drainage works are the backbone of integrated water management in irrigation systems. They ensure smooth intersection of canal and drainage lines, prevention of flooding or waterlogging, delivery of uninterrupted irrigation to farmlands. We explored the major types: aqueducts and siphon aqueducts when canal passes over, super passage and siphon when drainage passes over, level crossings where both meet at the same level. We also understood how site conditions, water levels, cost, and maintenance influence the selection of structure. And finally, we reviewed the hydraulic and structural design aspects that ensure long-term performance. Whether you're a student preparing for exams, a civil engineer planning a project, or a contractor managing execution, a solid understanding of cross-drainage works helps you build better, more resilient infrastructure. So, what's your experience with CD Works? Comment below. Don't forget to like, subscribe, and share if you found this helpful. Stay tuned for more civil engineering content only on Civil Engineering Edge. Until next time, build smart and build strong.